So for this video, we'll be talking about the PEMDAS. The PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. What this tells us is the order of operations to follow given an expression. So we first start with the parentheses. The parenthesis is usually denoted with this symbol, but we could also use a square bracket as well as this one. This one refers to the absolute value, which could also act as a parenthesis in an expression. After the parenthesis, we go on to the exponents. The exponents are usually represented by a raised to b, wherein b refers to the exponent. So some examples of this are 2 squared, 3 cubed, and such. For multiplication, we denote this by the times symbol or the scalar multiplication symbol. For division, we denote this by this symbol or the fraction symbol or this kind of fraction. For the addition, we denote it by the plus symbol, and for the subtraction, we denote it by the minus symbol. In terms of the order, we start off from top going down. We start with first the parenthesis. So whenever we see a parenthesis in an expression, we start the solving there. We follow by the exponents. So whenever we see this form, we proceed with that after the parenthesis operation. We then follow with either multiplication or division. So these two are interchangeable. Just take note that we go here from left going right in an expression. And lastly, we have the addition and subtraction, which is also interchangeable, but we also follow again the left to right idea. So let's try to apply these operations in some examples. We start off with this example. First, since this one is the parenthesis, we start out there. So we've got negative 10 plus negative. This one, we will have negative 13, which would give us minus negative 13. Now, for this one, note that since we are done with the parenthesis operation, we can actually remove the parenthesis already. So we then proceed with the exponents operation. However, there are no exponents out here. So we proceed with the multiplication and division. Now, although there isn't a present times symbol or scalar multiplication symbol, note that if an operation is followed by another operation, so in this case, the minus sign is followed by another minus sign, this implies that we multiply these operations out here. So that would give us negative 10 plus, so negative times negative would give us 13. Oops, I'll remove the operation to avoid the confusion. And for the other one, that is negative times negative again, would give us 13. Now, note that you could argue that the minus sign here is also followed by the plus sign. But if we do that, we will have in here a negative symbol. which would then again multiply to a negative. So we would still come up without it. But usually, if there is a plus symbol, we usually disregard it in multiplication, since nothing would really change. So we have this one. Now we can add all of this. So negative 10 plus 13 will give us negative 3. 3, since this one is higher. So that will have 3 plus 13, which would give us 16. So 16 is our final answer for this one. Let's go on to this one. Now first, again, we start with the parenthesis operation. So that would give us 1, bringing down the other operations. We'll have this one. Now for the next one, we proceed with the exponent part, but there is no exponent out here. So we go on to the multiplication and division operation. Since we go from left to right, we have this one first. So that would give us 5 plus 12 divided by 1. Then since 12 divided by 1 would give us 12, we have 5 times 12, or simply 17. Let's go on to our third example. Now for this example, note that we have an absolute value out here. And since it's the innermost parenthesis, we start with that. So this one would be 1 plus negative 2 inside the parenthesis would give us negative 1. Minus 1, minus 2, minus 1, minus 2. Let me use a different color for this one so we can clearly see it. Now note that when we use the absolute value, what we do is we convert the number inside into its positive form. So this negative 1 would actually become 1. So we would have 1 minus 1 minus 2 minus 1 minus 2. Now, solving for the operation inside this parenthesis, that would give us, since it's just simple addition and subtraction, that would give us 1 minus 1 first would give us 0 minus 2, or simply negative 2 minus 1 minus 2. Now, again, we can already remove the parenthesis out here since it's only a single expression. Now, since all of this are a subtraction symbol, we can simply subtract all of this. So negative 2 minus 1 would give us negative 3, minus 2 would give us negative 5. And that is the answer. For a fourth example, we have a more complex now operation, but we'll still follow the process. So first, we start with the parenthesis operation out here. Inside the parenthesis, we start with the exponent, since that is the rule for PEMDAS. So we have 40 plus 16 divided by 2 squared is 4. So 4 times 5 divided by 5 times 3 minus 2. For this one, so we start from left to right inside the parenthesis since it's multiplication and division. So we have 40 plus this one would give us 4 times 5 divided by 5 times 3 minus 2. For this one, inside the parenthesis, we do this operation, which would give us 20 divided by 5 times 3 minus 2. Now we follow that one by this one, the last operation inside the parenthesis, and that would give us 4 times 3 minus 2. Again, since it's only a single expression, we can already remove the parenthesis out here. So now, for this one, what we do is, since there is a multiplication operation out here, we multiply that. So that would give us 40 plus 12 minus 2. Adding these two would give us 52 minus 2, or simply 50. Let's go on to our final example. Which of the following is not equivalent to 3 times 167 minus 1? For this one, we will try to apply the PEMDAS operations out here, as well as some basic real number properties, such as distributive property, commutative, associative, and such. Now for this one, note that if we add this one, this would become 167, or more specifically, it would become 3 times 167 minus 1. And again, since it's only a single single expression inside the parenthesis, we can remove the parenthesis, and that would give us this one. So this is not the answer that we need. For the next one, note that we can actually rearrange this one, since multiplication is commutative. So this would become -1 plus 3 times 167. Moreover, since the addition and the addition operation is commutative, we could actually rearrange this 2 if we treat this one as a larger number. So there we would have 3 times 167 minus 1, which is also same as the given. So this is not the correct answer. How about this one? Note that -3 times -167 minus 1. Here, note that in this one, we could actually factor out this negative symbol out here. So if we factor that out, we would have -1 times 3. Let's write this one, parenthesis, -1 times 167 minus 1. Now note that -1 times -1 is actually 1. So when we multiply that one, since multiplication is commutative, we would have -1 times -1 times 3 times 167 minus 1, which would give us 3 times 167 minus 1, or we could remove the parenthesis, since in this expression we still go with the multiplication first, so it doesn't matter if there's a parenthesis. So it's the same as the given. For the last one, let's just cross this out first. For the last one, note that this is actually a expression where 3 is distributed. So this is actually equal to 3 times 167. 3 times 167 minus 1. Although it looks similar to the given, this isn't really equal to the given, since in this case, what the operation that goes first is this subtraction. But that is incorrect, since in the given, although parenthesis is not in there, the parenthesis is actually in here, since the first operation that occurs is the multiplication. So we know that D is not equivalent to the given. So this is the answer that we need. So in this video, we have tried to explain the PEMDAS, as such the order of operations to follow in solving expressions, and we showed different examples applying it. So that is all for this video.